Good day, everyone. Welcome to this session where we delve into the fascinating world of AI-driven creativity. Today, we spotlight the groundbreaking work titled Rich Human Feedback for Text-to-Image Generation. This research addresses critical gaps in current text-to-image models by integrating rich, detailed human feedback directly into the training process. The team's innovative approach not only enhances image quality, but also aligns generated visuals more closely with textual descriptions, setting a new standard in the field. Prepare to explore how this method transforms the landscape of image generation. Let's dive in! In addressing the limitations of existing text-to-image models, our research integrates rich human feedback to significantly enhance image quality and relevance. This feedback is specific and actionable, allowing for precise adjustments to be made during the image generation process. Historically, the evolution of generative models has progressed from GANs and VAEs to the more recent state-of-the-art diffusion models. However, despite these advancements, a gap remains in the detailed feedback mechanisms necessary for fine-tuning these models effectively. Our approach introduces a novel training pipeline that leverages a vision transformer, VIT, and AT5 text encoder within a multimodal transformer framework. This setup allows us to integrate detailed annotations from our rich human feedback dataset, RLHF 18K, directly into the training process. This integration not only enhances the training, but also provides a pathway to generate higher quality and more relevant images. Let's delve into the key highlights and pivotal results of our research. We proudly present the first rich human feedback dataset, known as RLHF 18K, which marks a significant advancement in the text-to-image generation field. This dataset not only provides detailed annotations, but also enables our newly developed RLHF model to predict nuanced feedback that significantly enhances the training and fine-tuning processes of T2I models. Our approach transcends traditional binary ratings, offering a deeper, multifaceted understanding of image quality and text-image alignment. This rich feedback mechanism allows for more precise adjustments and improvements in generated images, ensuring they align more accurately with their textual descriptions. The results speak for themselves. We've observed marked improvements in image quality and relevance when fine-tuning T2I models using the feedback from our RLHF model. This method sets a new standard in the field, pushing the boundaries of how machine learning models interpret and generate visual content from textual input. Through this innovative approach, we're paving the way for more accurate, aesthetically pleasing, and contextually appropriate image generation. As we delve into the realm of text-to-image, T2I generation models, it's crucial to understand their widespread application across various sectors. These models are not only revolutionizing content creation in entertainment, art, design, and advertising, but are also extending their capabilities to image editing and video generation. This broad adoption underscores the importance of addressing the quality of generated images, which often suffer from artifacts, implausibility, and misalignment with text descriptions. To tackle these challenges, our study introduces a novel annotation interface, as illustrated on the left. This interface allows annotators to directly interact with the image, marking regions of artifacts and implausibility, identifying misaligned areas, and highlighting misaligned keywords. They also assign detailed scores for various aspects such as plausibility and aesthetics. This method provides a granular insight into the specific areas of improvement needed for each generated image, paving the way for more refined and accurate image generation technologies. As we delve deeper into the challenges faced by current text-to-image T2I models, it becomes evident that these systems often generate images riddled with artifacts and implausibilities. Common issues include distorted body parts, such as hands with more than 5 fingers, and objects that defy physical norms, like floating lamps. These inaccuracies not only disrupt the visual aesthetics, but also misrepresent the scenes described by the text prompts. Furthermore, the evaluation metrics traditionally used to assess these models, such as inception score, IS, and Fréchet inception distance, FID, primarily focus on the statistical distribution of image features across a dataset. While useful for gauging general model performance, these metrics fall short in capturing the finer details and nuances of individual images. This gap highlights the need for more granular and actionable feedback mechanisms in image generation evaluation, which can guide improvements in model design and training processes more effectively. In our pursuit to refine text-to-image generation models, we've introduced a novel approach centered around rich human feedback. This method directly tackles specific image quality issues by focusing on implausibility, misalignment, and keyword relevance. By developing a dataset and model that incorporate these detailed annotations, we provide a framework that not only identifies but also quantifies the nuances that affect the overall quality of generated images. Understanding and addressing these issues is crucial for the practical application of text-to-image models across various domains. Whether it's enhancing the aesthetic appeal in digital art or ensuring accuracy in advertising visuals, the quality and relevance of generated images are paramount. Moreover, our detailed feedback mechanisms serve as essential tools for iterative model improvement, allowing developers to refine and train more robust models. This approach ensures that the generated images meet both the creative and functional needs of users in real-world scenarios. In addressing the challenges of image generation, it's crucial to understand why previous solutions fell short. Traditional methods often lack the capability to provide detailed and actionable feedback, which is essential for refining the nuances of generated images. Moreover, the datasets previously used were limited in scope, either too small or lacking in diversity. This inadequacy hindered the development and evaluation of models that could effectively handle a wide range of real-world scenarios. By recognizing these limitations, we set the stage for introducing a more robust approach that leverages larger and more varied datasets, alongside advanced feedback mechanisms to enhance the image generation process. Let's delve into the core of our research, focusing on the innovative methods and the architecture of our model. We've developed a novel training pipeline that integrates rich human feedback directly into the model training process. This approach not only enhances the accuracy of our predictions, but also ensures that the feedback is deeply embedded in the learning phase, making the model highly responsive to the nuances of human evaluation. Our model, RLHF, is a multimodal transformer designed to capture and predict detailed feedback on generated images. It uses the VITB16 encoder for image encoding, which is configured specifically with a 16 by 16 patch size and multiple layers to efficiently process image data. For text processing, we employ the T5 base encoder, which excels in integrating text and image features, providing a robust foundation for our predictive tasks. The architecture also includes 3 specialized predictors. The first is dedicated to scoring image quality, providing fine-grained scores that reflect subtle aspects of image aesthetics and plausibility. The second generates heat maps to identify and highlight implausible regions within the images, guiding potential corrections. Lastly, the third predictor focuses on identifying text-image misalignments, ensuring that the generated images faithfully represent the textual descriptions. By integrating these components, RLHF stands out as a comprehensive tool for enhancing the quality and reliability of text-to-image generation, paving the way for more accurate and user-aligned content creation. Delving into the technical core of our research, we've developed a robust training process for our model. We utilize the RLHF 18K dataset, which is meticulously annotated with details such as implausibility regions and misaligned keywords, providing a rich foundation for training. To enhance the robustness of our model, we incorporated various image augmentations, including random cropping and color adjustments. This not only simulates real-world variations, but also helps in generalizing the model's performance across diverse scenarios. Our training strategy employs the Atom W optimizer. We meticulously adjusted the learning rate, starting with a gradual increase during the initial iterations, followed by a strategic decrease, which is crucial for stabilizing the model's learning as it converges. Furthermore, the integration of human annotated feedback into our training loop marks a significant advancement. This feedback refines the model's predictions, making them more precise and reliable. We also leverage the predicted feedback for fine-tuning our generative models. For instance, using heat maps as masks for inpainting and utilizing scores for selective data filtering enhances the model's ability to generate contextually relevant and visually coherent outputs. This meticulous approach not only improves the model's accuracy, but also its applicability in real-world scenarios, ensuring that the outputs are both meaningful and practical. Let's delve into the technical intricacies of our rich automatic human feedback model, or RLHF. The model begins by processing the input image and its corresponding text through separate encoders. This dual pathway allows for a nuanced understanding of both visual and textual elements. Once encoded, the model applies a series of predictors that assess various aspects of the image, such as plausibility and text-image alignment. These predictors integrate their findings to produce detailed annotations and fine-grained scores, pinpointing specific areas of improvement in the generated image. Moving on to our experimental design, we meticulously crafted experiments to validate the effectiveness of RLHF. We compared the model's predictions against human annotations, focusing on their correlation and accuracy. This rigorous testing ensures that our model not only mimics human judgment, but does so with a high degree of reliability, making it a robust tool for enhancing image generation technologies. Moving forward, let's delve into the significant improvements our research introduces over previous methods in text-to-image generation models. Traditional feedback mechanisms typically provide binary ratings or single-score evaluations, which, while useful, often fail to capture the nuanced issues present in generated images. Our approach, however, leverages detailed, multifaceted feedback that not only identifies specific regions of implausibility and misalignment in images, but also provides fine-grained scores across multiple aspects such as plausibility, text-image alignment, aesthetics, and overall quality. This rich feedback mechanism is instrumental in offering more actionable insights. For instance, by pinpointing exact problem areas within an image, developers can directly target these regions for improvement, rather than making broad, less effective adjustments. This level of detail and feedback is unprecedented in the field, and sets a new standard for how we evaluate and enhance text-to-image models. Let's delve into the technical results achieved with the RLHF model. As illustrated in the figure, the architecture seamlessly integrates vision and text streams, processing these to generate detailed heat maps, scores, and text sequence predictions. This integration is pivotal for understanding the nuances of image quality and alignment with text descriptions. Our key findings indicate a high correlation between the RLHF model's predictions and human annotations on the RLHF 18K dataset. This alignment underscores the model's accuracy in capturing human judgment, which is crucial for training more reliable text-to-image generation models. Moreover, by incorporating this rich feedback directly into the training process, we've seen a notable enhancement in image quality. This approach not only addresses common issues like artifacts and misalignment, but also pushes the boundaries of what automated systems can achieve in terms of aesthetic and functional outputs. Let's delve into the technical results achieved through our rich automatic human feedback model. We've observed quantitative improvements in image generation quality when using RLHF for fine-tuning. Specifically, this has led to a noticeable reduction in artifacts and better alignment with the text descriptions, enhancing the overall aesthetic and plausibility of the images. Our statistical analysis robustly confirms these improvements over baseline models, marking a significant advancement in text-to-image generation technology. Moving on to our ablation study, we meticulously assess the individual components of the RLHF model to understand their contributions to its performance. The results highlight that the heat map predictions are crucial for identifying and correcting areas of implausibility and misalignment in generated images. Additionally, the fine-grained score predictions have proven to be effective tools for guiding the fine-tuning of image generation models, ensuring that the enhancements are not only perceptible but also quantifiable. This dual approach allows us to refine image quality in a targeted and efficient manner, setting a new standard in the field. The RLHF model introduces a transformative approach to training text-to-image generation models by providing detailed, multifaceted feedback. This feedback includes heat maps that highlight areas of implausibility or misalignment, scores that assess various aspects of image quality, and keyword alignment that pinpoints discrepancies between the text prompt and the generated image. These elements are crucial for refining model performance, as they allow for targeted improvements in specific areas that traditional metrics might overlook. Moreover, the potential applications of the RLHF model extend beyond text-to-image generation. Its ability to provide granular feedback could be instrumental in other domains of generative modeling, offering a pathway to enhance the quality and reliability of generated content across various fields. This opens up exciting possibilities for future research and development in generative AI technologies. Let's delve into the transformative impact of the rich automatic human feedback model on generative models, illustrated here with before and after images. These visuals compellingly demonstrate how fine-tuning with RLHF predictions not only enhances the overall image quality, but also significantly improves alignment with text descriptions. Turning our focus to the rich human feedback dataset, or RLHF 18K, it's important to highlight that this is the first dataset of its kind. It provides detailed annotations that pinpoint image artifacts, misalignments, and keyword relevance across 18,000 images from the PIC-A-PIC dataset. This rich, multifaceted evaluation approach marks a significant advancement in how we assess and refine text-to-image generation models. Let's delve into the development and impact of the RLHF model, our multimodal transformer designed to enhance text-to-image generation. This model stands out by predicting detailed feedback on generated images. It identifies specific regions of implausibility and misalignment, and it provides fine-grained scores assessing aspects like image plausibility, text-image alignment, aesthetics, and the overall image rating. Our evaluations show that this model significantly improves image quality and relevance. By incorporating rich feedback directly into the training process, we've seen enhancements in image-text alignment and the overall quality of the images. Furthermore, the RLHF model has been instrumental in improving image generation techniques. It uses predicted heat maps to inpaint problematic regions and employs fine-grained scores to fine-tune generation models, leading to more accurate and aesthetically pleasing outputs. This approach not only refines the images, but also aligns them more closely with their textual descriptions, achieving a higher level of coherence and fidelity in generated content. Rich and detailed feedback is crucial for the advancement of text-to-image models. By providing specific and actionable insights, we can significantly improve the quality of image generation. This approach allows for a deeper understanding of image quality that goes beyond simple binary ratings, offering a more nuanced view that is essential for refining these technologies. Furthermore, integrating human feedback directly into the training process of these models not only enhances their capability, but also ensures the generation of more relevant and high-quality images. This method sets a new standard for training text-to-image models, pushing the boundaries of how we understand and improve image quality based on nuanced human evaluations. This integration is pivotal in developing models that can truly meet user expectations and perform well across a variety of real-world applications.